Good afternoon. On behalf of Engineers Australia, I'm delighted to welcome you all to our Thought Leader series, Maintaining Uninterrupted Reliable Power Supply. My name is Megan Purdy and I'll be your host for today. Firstly, in keeping with our custom, Engineers Australia acknowledges the traditional custodians of the country throughout Australia and recognises their continuing connection to land, waters and community. We pay our respects to them and their cultures and to elders past, present and emerging. Before we get started, I would like to acknowledge that today's webinar is being hosted with Engineers Australia's industry partner, ABB. ABB are pushing the boundaries of technology to help build smarter, greener cities of the future today. By innovating how people work, live and move, ABB is creating solutions that enable its customers to reduce their carbon footprint while maintaining operational excellence. Now today, we'll hear from our speakers, followed by our live audience Q&A, and I encourage you all to please send your questions through to our speakers via the chat box. I'd now like to welcome our first speaker, Adam Cockshell. For over 13 years, Adam has navigated the intricate realm of critical power with a focus on uninterruptible power supplies, power quality, and power conditioning systems. His foundation in field service has infused a practical perspective into his former position as product manager and his current role as a business manager for power protection at ABB. Please join me in welcoming Adam Cockshell.
Appreciate the introduction, Megan, and thank you for joining Shun, Malad, Sorchin and myself today. The critical power segment is growing rapidly due to the increasing demands for reliable and uninterruptible power across almost all industries. The growth of critical power applications is being driven by several factors, including the increased use of IoT devices, AI, sensitive equipment, and of course, the growth of cloud computing and data centers, and the need for business continuity and disaster recovery solutions. How can we ensure the highest availability along with the highest efficiency? Looking at the Melbourne data center market, for instance, according to DC Byte, the growth in total market capacity of data centers is 27% per year during the last 5 years. I would like to take the opportunity today to illustrate the products that we have developed here at ABB, addressing the new era of critical power. ABB's unique approach to modular UPS design incorporates all the hardware, software needed for autonomous operation. That is the rectifier, the inverter, your battery converter, static bypass switch, backfeed protection, control logic, display, and monitoring systems. With all the critical components distributed between the individual modules, this system is fault tolerant with no single points of failure. ABB calls this decentralized parallel architecture, or for short, DPA. ABB's DPA modular UPS range is designed to make sure that power is always available when you need it. Each high reliability standardized module is self-contained, fast to service and maintained with short MTTR, that is mean time to repair, thanks to the online swappability of the modules, front serviceability and smart design. It takes less than 10 minutes to replace a module, so nothing needs to ever be switched off. And if you ensure the commonality of DPA modules across your site, you ensure an ease of spare parts and obviously the ease of maintenance. With a module efficiency of up to 97.6 whilst in double conversion mode, we not only have an easy to maintain design, but an extremely efficient. To add to the efficiency across the loading of the UPS, we can also enable what we here at ABB refer to as extra VFI to provide higher efficiency at low loads, showing here that at loads as low as 15%, we can achieve 97% or greater. Extra VFI in our DPA architecture allow us to have the load supported, or N nominal, with a spare module, your +1, always maintained to your critical load in an active state, with all additional modules placed into a standby state, this moving the load profile to a more efficient loading zone. The standby modules are ready and waiting, and if required, can come on due to a load increase. To ensure the modules age evenly, they rotate through an active and through a standby mode evenly throughout the life of the UPS. HyperGuard. ABB's industry-first medium voltage UPS that provides continuous and reliable power for up to 24 kV for mission-critical facilities. With the highest level of efficiency available in the market at 98%, translating to a potential carbon emission reduction of up to 1,400 tonnes over a 15-year lifespan. The transition from low voltage to medium voltage level is a natural progression for power protection for large critical power facilities. Among the most significant benefits is the reduced cost to the critical power facility build and operation. Larger protected load banks, lower switchgear count, reduced size of busways and cabling with lower losses. HyperGuard is designed with long-term system availability in mind and only requires maintenance, an intrusive maintenance in every 10-year interval, delivering time and cost savings for maintenance teams. ABB's ZISC, Z-I-S-C, impedance isolated static converter, is a high-performance, high-efficiency power conditioning and uninterrupted power supply architecture. ZISC architecture is based on an isolating line reactor coupled with high-performance ABB power converters. This simple approach, backed with advanced control, provides unmatched reliability in performance with class-leading efficiency. Decoupled from the utility via the isolating line reactor, the power converters continuously condition and filter utility disturbances, voltage imbalances, without cycling the energy storage. Load-related events such as downstream faults and other dynamic reactive current demands are managed with ZISC's high overload capability. The isolating line reactor and coupling transformer are applied at medium voltage, whereas the power converters and energy storage at low voltage, thus simplifying the maintenance regime. The HyperGuard's 2.5 MVA system output is designed with redundancy in mind. With ABB's modular approach to power protection, the HyperGuard delivers on its 2.5 MVA output with 1, 2, or 3 inactive modules having no impact to the output capacity. Combined with a wide range of modern energy storage, ABB's HyperGuard provides autonomies from a few seconds to many minutes. ABB's PCS100 AVC40 active voltage conditioner is a converter-based voltage regulation device that can be connected between the main supply and sensitive electrical equipment or machinery to protect against supply anomalies, ensuring a clean, stable voltage and providing instant voltage sag and surge correction, ensuring maximum productivity. Through ABB's bidirectional PCS100 converter modules, a compensating voltage is either injected or absorbed with respect to the event experienced. It offers plus or minus 10% constant voltage regulation, as well as 100% voltage correction from 60% voltage remaining across 3 phases, back up to 100% for up to 30 seconds, or a single phase sag down to 50% voltage remaining up to 100% for up to 30 seconds as well. Partial correction from 0 volts, correction of all phase angle errors, and correction of utility supply imbalance. More than 90% of financial impact due to power quality events as a result of sags. The PCS100 AVC40 has no energy storage and is designed for industrial loads. It features a 99% efficiency. Our PCS100 AVC40 has a capacity through 150 kVA through to 3.6 MVA. When it comes to our DPA UPSs, our DPA upscale 10 and 20 kilowatt DPA UPS modules, scalable from 10 kilowatts all the way through to 400 kilowatts. Our Powerline DPA, which is our industrial modular UPS, has 20 and 40 kilowatt DPA UPS modules, scalable from 20 kilowatts through to 1.2 megawatts. Our DPA 250S4, 50 kilowatt DPA UPS modules, scalable from 50 kilowatts all the way through to 1.5 megawatt. DPA 500 with its 100 kilowatt DPA UPS modules, scalable from 100 kilowatts through to 3 megawatt. Our Megaflex DPA with 250 kilowatt DPA UPS modules, scalable from 250 kilowatt all the way through to 6 megawatt. Therefore, our DPA UPS family is scalable from 10 kilowatt all the way through to 6 megawatt. Our HyperGuard MV UPS has system blocks of 2.5 MVA with a parallel capacity up to 25 MVA. In order to increase the redundancy and reliability of a critical power infrastructure, you can add an STS, or a static transfer switch. Typical design incorporates two separate supplies. So obviously your source 1 or source A and your source 2 or source B, feeding a preferred and an alternate source of the STS. Our CyberX DSTS, or digital STS, continuously monitors power quality on both the preferred and alternate sources and transfer accordingly in the event that the power quality deteriorates beyond the user-defined thresholds. In this illustration here, you can see a source A and a source B being directly fed from the grid. In this instance here, we're adding an AVC to source A, so to provide some form of power conditioning. Supplementing the AVC in this instance for a UPS on source A, more commonly used with a UPS on source A and source B. It's illustrating the different applications that a STS can be used in. What I'd also like to draw your attention to is how we can go from a tier 1 configuration into a tier 2 configuration without having any impact to the footprint of the UPS. So in this instance here, you can see that we've got a DPA 250S4 in parallel configuration with a system rated power output of 400 kilowatts. So in this instance, that's 4 modules in each one of those frames. So 400 kilowatt output. Without any increase to our footprint here, we've been able to go from a tier 1 design to a tier 2 design, including an N+1 in the system here. So remembering that our DPA UPS modules are exactly that. They are UPS modules. So you're providing the redundancy down to a UPS level. We are in the business here at ABB of paralleling UPSs. Thank you very much for your time. I look forward to joining you in a few moments' time when it comes to question time. Thank you.
Thank you, Adam, for your input today. I'd now like to welcome our next set of speakers. We'll have Shan Muzata and Milad Mostafala. I'll start with introducing Shan. Shan is Australia's Product Marketing Manager for ABB's Energy Distribution product portfolio. In this role, he is responsible for business development of residual current device, miniature circuit breaker, fuse gear and switches, and energy management system. He has experience working in ABB Japan for 7 years for a similar role and working for ABB Australia for almost 5 years. He is passionate about protective device of DIN rail products and digitalisation of sub-distribution board with ABB Energy Management System. And with regards to Milad is a Senior Product Manager in Electrification, Smart Power Division at ABB, and practicing registered Senior Electrical Engineer with expertise in energy distribution and electrification. He has been consulting with clients across small, medium and large enterprises, including commercial, industrial and government sector in Australia, Europe, UK and New Zealand, supporting them to incorporate electrification solutions. Milad shares a passion for electrification, energy transformation, digitalisation and efficiency. Please join me in welcoming Shan Muzata and Milad Mostafala.
Thank you, Megan, for the quick intro. My name is Shun Mizuta, and I have Milad Mostafala with me to cover the section of ATS and embedded ATS. Let's talk about transfer switches. Transfer switches are an essential component of power supply applications, allowing the application to convert to stable power source if its current power source is turned off or failed. Whether a power source failure is planned or unplanned, a reliable switching device is crucial. Now, let's look at the different classification of transfer switches. We have four different switching devices. First one is circuit breaker technology base. We call it class CB. Second one is switch base, class PC. Third one is contactor base, class CC. And we have static transfer switch. We have different controlling methods. First one is manual transfer, and second one is remote operation. The third one is automatic transfer switches, which we will going to talk about. We have three different transition types. Delayed transition, for this case, there is a stable off position in between the transition. Second one is open transition. So the transition will happen directly from primary source to secondary source. Third one is closed transition. There you can see there is overlapping period between transition. In the IEC region, delayed transition is more preferred and making 99% of the market. On the other hand, in UL region, open transition covers 80% to 90% of the market. Now let's look into different classes. Class PC and Class PC, which is contactor base or the switch base. They are more cost-effective solutions, but it doesn't have the protection, circuit protection functionalities. Whereas Class CB has overcurrent or short circuit protection. It is more expensive, but it can usually cover higher current ratings as well. This is ABB offering. We have wide range of ATS to cover the market requirements. The top two, True One and ACB base ATS, are the ones we are going to talk about today. But we have other ATS covering basic functionalities and lower current ratings. Our range can cover up to 6300 amps, which is a quite wide range. Now, this is True One. Many of the existing solutions out there are made from the components where the mechanical parts are separated from the electronics. So switches, contactors, breakers, and loose controllers, even different brands are put together to make up one ATS, creating a complicated wiring and logics. This would be a complex solution instead of fulfilling the simple need for one product that transfers the source when needed. So, if you look at the picture on the left, that's the conventional type of ATS. You see many components are wired together, very complex design. Now, True One has put everything into one device. It also has in-phase transfer time below 50 milliseconds, which is one of the quickest in the market. And it has manual operation ready to be used in case of emergency. You don't need to disconnect source one or primary source or secondary source to do that. Manual operation is ready when the power is on. There's other functionalities such as overlapping neutral, which comes as a standard model. And overlapping neutral is sometimes required for specific applications. We have also ABB Ability connectivity. ABB Ability is cloud-based service, and True One can be connected to ABB Ability and ABB Ability to feedback with the predictive maintenance. That's something very nice to have in case you need to have the connectivity to the upper EMS. Then True One is surely the perfect solution. This is one example of application. The continuous power supply is one of the most important aspects of hospital operations. IEC defines two groups of patient area, Group 1 body protected room and Group 2 cardiac protected medical locations. For Group 1 and 2 room, the IEC standard defines a minimum period of time the backup source shall maintain the power supply for the safety service and also change over time. In this specific case of Group 2 medical locations, the ATS has to restore the power within 500 milliseconds. In addition to that, the ATS equipment must be integrated in a monitoring system with a cloud-based connectivity. So True1 was certainly the perfect solution to be used for this project. Now I'm handing over to Milad.
Thank you very much, Mr. Shun. So following to the automatic transfer solution based functions that we have here, the second part is the circuit breaker based automatic transfer solutions that we have as part of our portfolio. These are what we call as embedded ATS range, and they vary from 630 amp to 6300 amp within the Emax2 family. And we do even have a smaller range in terms of amp sizing. It can get as low as 16 amp to 1600 amp within the XT range of our portfolio. They are able to talk and communicate in 9 different protocols, and simultaneously you are able to have them connected to your SCADA system or whatever controlling system that you are having for your end client. For those of you who are interested or who have clients who are interested in UL functionality, these range are also classified as part of UL, so you're able to utilize them as part of the UL standard as well. The circuit breaker based automatic transfer solution that we have sort of categorized into two. One is the main gen type, and the second one is the main tie main closed function. And technically, you are able to sort of use them with our EKI platform, which means that there's no need for any external controller installation or programming. So moving forward in terms of how to utilize this embedded circuit breaker based solution, as you can see on right hand side of your screen, the most typical type is the main tie main characteristics. So in this example, you are looking at 2 connections from the transformer and the utility, and beneath on the lower right hand side of your screen, you can see the main gen types of functionality that can switch over between the mains connection and the generator connection. Next, I have prepared some reference design or application examples that I believe could be useful for you guys within the design sort of structures. So first, let's start with the critical power application example. In this reference design, this client was interested to utilize the embedded circuit breaker based solution because of the functionalities and the benefit that the solution was able to provide for their facility. The major part was obviously the space saving in terms of real estate, and simultaneously the time to commission and time to operate that had reduced engineering hours involved in terms of programming was also of benefit to this client. So this particular project was a facility with total input power of 1 megawatt, and the load profile for this client was around 550 kilowatt. As you can see, they were able to utilize the circuit breaker based automatic transfer switching in the connection between the transformer and the generator side. They were able to utilize a 1600 amp circuit breaker sizing for this facility. And what was very interesting for this particular project was the simultaneous use of the circuit breaker based automatic transfer switching for this critical power application, together with the True One ATS system simultaneously. And that was quite successful for the end client within this project. So that was the first reference design example as a critical power application reference. Second, I would like to talk about a building services application case. So as you are aware, or most of you are dominantly very active within the building services portfolio. And the main challenge was obviously for this client was to guarantee operation of the sort of simultaneous operation of the facility. They were looking at a 1500 kVA transformer connection from the utility provided to them in this building services example, and they were able to use the main tie main scenario with the 2000 amp size for the main tie main function, and obviously with that they were able to provide the benefits in terms of faster time to operate, less reduced engineering hours, and quicker commissioning in terms of operation. For this building services client, there was also the case of use with True One itself in terms of connection between the generator and the mains, and they were able to benefit from the sort of functions that True One was able to bring into the table for their project. Moving along to our next application reference design. This was an industrial application client who was interested to utilize the embedded circuit breaker function automatic transfer solution, and they were able to utilize the main tie main function here with the use of 3200 amp sized functionalities. This client had a 2000 kVA transformer connection, and the challenge that they were facing or they were wanting to sort of resolve was the need to have 50% of total installed power supplied at any time for their plant. There was quite a complex measurement and communication involved in this project, and with the use of the embedded circuit breaker based automatic transfer solution, they thankfully avoided to go through the installation of CTs and VTs and measurement and analytics and separate communication or protocol converters, and they were able to communicate to the local control system quite seamlessly with this design. So with that was the case with our application reference design. What I have prepared here is a few system design examples for your reference in terms of continuous operation, which I believe you can benefit as a key takeaway from today's session. So first type of system design example is a fault sensitive type of design, as you can see on the left hand side of your screen. Second type is a redundant design, that you are able to provide redundancy factor within your system. And third is the concurrently maintainable types of design. So this is the case when you are able to provide maintenance function within the facility for your end client. And last one, which is the most complex and is becoming more of a common occurrence these days, is a fault tolerant design that can guarantee a continuous operation for your client, and you can take as a key takeaway from today's session. Thank you.
Thank you, Shan and Millard, for your input. I would like to welcome back Shan, who will now share his insights on the topic.
Okay, Now we will discuss about ABB digital solutions. First solution I'm going to introduce is Insight. The digitalization of the equipment is all over the industry. It is no exception for distribution board. Insight Energy Management System is designed to visualize what is going on in the sub-distribution board. It will help to identify if the load or system is showing abnormal trends and prevent unexpected failure of the equipment. Insight is for small and medium scale facilities, especially for critical power applications, and also commercial and residential buildings. ABB has two models of Insight, 1.0 and 2.0. One is one comprehensive control unit. On the other hand, 2.0 is modular design control unit, separating the functions into modules, which will be attached to the control unit. Let's look into the Insight 2.0. The control unit is too wide, 2 module width like this. If you want to measure your current or energy of final sub-circuit of MCB, you add this ribbon cable. Then you can add current sensors. We have solid current sensors or open core current sensors. If you want to also connect your auxiliary contacts of MCB, we have smart auxiliary contact, which will have direct connect to the ribbon cable. If you want to add more functions from the modules, for example, here you need to have power supply 240 volts to add additional modules, such as energy meter modules like this. And if you want to add multiple of them, that is also possible, up to 5 modules. If you want to add additional protocol, for example, wireless M-bus, we also have module for that. Here, we have connectivity with Modbus RTU. Insight 2.0 can connect up to 16 Modbus devices, such as EV chargers, PV inverters, energy meters, or energy analyzers. Power analyzers. Power analyzers are like to measure the power factors or total harmonic distortions or sorts of power quality parameters. You can also connect to our MCCB or ACB through Modbus RTU. And similar to that, we have one Ethernet port RJ45. Insight can connect up to 16 Modbus TCP IP devices like this. And so Insight 2.0 has a great connectivity to other field devices, including third-party Modbus devices. Here we have Wi-Fi functions. Insight 2.0 can come with Wi-Fi connectivity, which means you don't need to have Wi-Fi router to connect to internet. Insight will have 3 GB data storage, but if you want to add more data, there is a slot on the bottom. You can add SD card there. Let's look at Insight 1.0. As I said, it is one comprehensive control unit. It can work as one energy meter by adding external CTs. If you want to add current sensors, you can also do that. In case of auxiliary contact, you need to have I/O module in between. Again, Insight 1.0 also have Modbus RTU device connectivity and also Modbus TCP IP connectivity. One thing different from the Insight 2 is Insight 1.0 can have multiple inside control unit in one system, and you can configure one of them as a master device. A master device will be data collecting point of the rest of the control units. This is an example of Web UI. As you can see, it is very intuitive design. You have the menu on your left, and this is what you're seeing is a dashboard. And you can always add a dashboard as you like. You can modify and change the widget that you want to visualize. And there is a load management functionalities. You can program the inside and control the MCB switching on or off as you like. There is other functionality, a lot of functionality such as reporting or alarm. We can cover more about these functions when we come down to the more in-depth program webinar coming up in a few weeks. Here is one application node of Insight. In this case, we connected multiple third-party Modbus meters to Insight, and this particular case required the Insight to talk to the upstream energy management system, which is also possible through Modbus RTU or Modbus TCP IP. So Insight was the perfect solution for this particular project. Thank you very much for hearing.
Thank you, Sean, for your input. I would now like to welcome our next speaker, Sorshin To. Sorshin brings with her more than 15 years of experience in medium voltage product applications. She held multiple roles within ABB and now working as the product marketing manager for medium voltage switchgear. She supports various market segments to improve switchgear maintenance strategies, be proactive in digital substation transformation, and working on solutions to increase asset availability. Please join me in welcoming Sorshin To.
Good afternoon, everyone. I'm excited to be here introducing ABB switchgear condition monitoring system that will bring the medium voltage switchgear maintenance to a whole new level. I really like how it's act like an eye to the users to help them to look into the switchgear without opening the panels. Today, I'm going to take you through the advantages of condition monitoring and how it will help to shape the new ways of working with digitalization. In a plant, we usually face challenges in asset management. The user often have to look at ways to improve the availability and reliability of physical assets while thinking of ways to minimize the risk as well as the operating costs. There's a lot of pull and push factors here. The asset manager, the facility managers, or the maintenance managers often need to evaluate the situation based on the asset conditions. For example, if the switchgear is installed in the clean indoor environment or it's at the outdoor, very dusty environment, the risk and failure of consequences, for example, if there's any design that has already catered in the redundancy, or how fast a system can come back online after a failure. And also, of course, the life cycle of the equipment is also very important, as in how long you have been using the piece of equipment, if this is still active equipment by the OEMs, is there any availability of spare parts? All these items will have to be taken into consideration to decide the optimum maintenance strategy. There are normally two key types of maintenance at site here, preventive maintenance and corrective maintenance. Corrective maintenance is also known as run to failure, works on the principle of performing maintenance only when the problem occurs. This type of maintenance has the highest risk of production or service loss, and the probability of failure is not under control. The second type of maintenance is the preventive maintenance. It is time-based maintenance. it is regularly scheduled either by using the time intervals or usage as a trigger. The probability of failure is more controlled due to the frequent inspection that could actually predict or foresee the breakdown. If you look at the chart on the left-hand side, the top right-hand corner of the chart, you will see the condition-based maintenance. Yeah, it is more proactive and predictive maintenance strategy, which can be implemented with the help of digitalizations. Yeah. Though it is with a higher upfront cost, in long term, it will actually reduce the labor cost by centralizing the data collection and analysis. Now, how condition-based maintenance can help? By knowing the real-time asset condition, we are able to transform the time-based preventive maintenance to an advanced maintenance technology. We can carry out the risk assessment based on the condition of the asset, which is available 24/7, and only perform the necessary maintenance when and where it is required. This will reduce the maintenance costs, for sure, because the periodic manual inspection is no longer required. Intervention will be planned at a much better timing to avoid service disruption. This is by far the most effective and sustainable strategy. The operational budget can be used far more effectively by performing assessment in order to prioritize the work and also the focus of the maintenance team. Condition monitoring doesn't mean that the system is maintenance free. It is there to optimize the whole process of maintenance. The two tables shown on the right-hand side of the chart is the comparison between the standard and the condition-based maintenance for switchgear, including its key components, for example, the circuit breakers, the panel itself, and also the protection relays which are installed inside the panels. The top table is for the switchgear without monitoring and diagnostic features, and the bottom table is for the switchgear with condition monitoring features included. These tables are developed based on ABB experience, of course, and we actually adopt see, watch, act, and perform strategy. C is, for example, is an overall inspection of the panels, which doesn't involve shutdown. You're looking at the external of the switchgear. Watch is for a more in-depth inspection into a certain component or the parts of the switchgear, which may involve de-energizing the panels. Act is to perform the basic maintenance, for example, cleaning, lubrications, or function tests of the equipment. And perform is the advanced maintenance, which include repair and reconditioning or refresh of that particular equipment. When sensors and condition monitoring are used, the customer can usually skip the basic visual inspections. Advanced maintenance is still required on occasion, as sometimes it's just too high cost to monitor everything. However, when it is required, the time taken is actually reduced because the maintenance is focused on part that is based on what condition analysis and diagnostic have indicated. And depending on the analysis, we can prolong the maintenance interval or the cycle of the maintenance, hence increase the equipment availability. Overall, it could be stated that using condition-based maintenance, it could reduce the high cost of unplanned labor. Another conclusion is that such maintenance leads up to about 30% decrease in maintenance time. Together with the reduction in labor and maintenance cycle, this could then lead up to about a total of 40% reduction in operating expenditure. Another specific area of safety concerning many customers is protection against arc flash. We wanted to keep the personnel away from the arc flash zone as much as we can, and by having the key data available at their fingertips remotely is a way of increase the safety on site. We also wanted to maximize the uptime and avoid the unplanned outage costs. Different industry will have different outage costs, of course. Digitalizing the switchgear will help to detect the common issues before the system fails. Yeah, common issue, for example, like loose connections or joints, environmental condition, for example, if it's the dust or the humidity, and faulty installations. Yeah, all can be detected earlier with condition monitoring. This will help to avoid the unnecessary equipment breakdown, and intervention, if required, can be planned at the time with minimal interruption to the plant operation. Now let's have a look at what we can offer. Yeah, our condition monitoring system is a scalable system connecting all the intelligent devices within the switchboard to provide a real-time supervision of the asset condition. The data will be collected and analyzed in a smart unit called SWICOM, the unit that's shown in the middle of the chart. The SWICOM will then analyze the data before send them to the SCADA system. In the SWICOM unit, we have actually algorithm built in to analyze the data. Yeah, it's not just displaying the raw data. It will then, based on this data, analyze, calculated it, and then based on the algorithm, and then it will then display it as a traffic light system for the users. Yeah, for example, red is as in there's some abnormality in the data collected. Orange is there's some something that you may need to check, and green meaning all good. Yeah, this will actually help the users to understand the root cause easily and plan for the intervention accordingly. Other than SCADA, SWICOM unit can also be connected to a cloud by subscription to ABB Ability platform, which Milad, my colleague, is going to talk about it after this. This will then enable the advanced maintenance using the support from ABB. There are 4 modules included in SWICOM, namely the breaker diagnostic, the partial discharge detection, the temperature diagnostic, and the data visualization module. The first module is the breaker diagnostic module, which will provide the advanced warning on mechanical and electrical abnormalities within the circuit breakers. The second module is the partial discharge detection, which will prevent upflash and equipment sudden breakdown. The third module is the temperature monitoring. This will help to detect the hot joints and unbalanced load, to prevent all the temperature-related failures in this case. The data visualization is the last module, which then help to display the health conditions of the switchgear in front of the switchboard or remotely at plant level control room. This slide will show you the high-level architecture of the SWICOM switchgear monitoring system. Yeah, first let's start with the circuit breaker monitoring. This is done through the rely-on protection relays, namely the 615 families, the 620 families, or the 640 relays, which is already installed within the switchboard to provide the required protection functions. Yeah. These relays will then be connected to the SWICOM unit through the IC 61850 bus. The second module is the partial discharge detection. This is done by using the capacitive coupling methodology to a unit called PDCOM. This PDCOM unit can provide a continuous PD detection for up to 10 panels. The third module, which is the temperature monitoring, they can be connected either by wired infrared devices or the wireless temperature monitoring devices. They can all be installed in the busbar compartments, the circuit breaker compartments, or the cable compartments of the particular switchgear, depending on your requirement. Then all these detection devices will then be connected to a SWICOM unit, and the data will be available for viewing through SCADA system, ABB Ability Asset Manager, the local HMI of the SWICOM unit, or even through the mobile app, which you can install in your tablet or your phone. And then by scanning the QR code on the SWICOM unit, you can then see the same display as the SWICOM unit. The SWICOM unit is available for connection to the upstream through IC 61850 communication or Modbus TCP/IP communication. As this system is fully scalable, they can either be installed in a new switchgear or added on to the panel later. Far from being a change which we aren't ready for, The transition to digital-enabled system can be a progressive journey for business towards greater sustainability, cost efficiency, and operational intelligence. That brings me to the end of my presentation. Thank you very much for your time.
Thank you, Sochim, for your input. I'd now like to welcome back our speaker, Milad Mustafabala, who will now share his insights on the topic.
Thank you very much. In terms of critical power and application for energy management and asset management, one of the items that we are pleased to be able to present is the ABB Ability Energy Manager for critical power application. One of the success cases that we were able to implement the ABB Ability Energy Manager for a critical power application is the system that you are able to see and view in your screen on the right hand side. In this system, we were able to provide the energy management monitoring for this end client. Together with the connection to our portfolio that was presented today. And the benefit that this client was able to take away was having the complete monitoring and autonomy of their plant and facility out of the system through the ABB Ability Energy Manager. The second option, or the second sort of function that we are able to provide or present in projects and for clients, is the ABB Ability Asset Manager, which can be used for critical power application. Within this part of our solution, condition monitoring, health analysis, troubleshooting are some of the key features of the ABB Ability Asset Manager. I have to sort of re-emphasize as well on Smart Tracker as one of the asset manager tool that's used for our UPS system, and it's able to provide the relevant alerts and monitoring for the critical power application as well, and provide that to multiple users simultaneously. So one of the key functions or benefit of the asset manager is having the health overview of the assets involved in terms of their trends and their service activity and how they are tracking throughout the time when in operation. And that's the benefit for a critical power application that this solution is able to provide. And lastly, what we have prepared for you today is an application example for the critical power system, which utilize the energy manager and asset manager simultaneously together, while being able to utilize the existing SCADA system without interfering with that control functionalities of the client with their existing SCADA system, which was a 61850 control-based system. So what you are able to view on your screen in this reference design is the application of the energy manager and asset manager simultaneously with a 6150 controller based design that's sort of benefiting this client in terms of monitoring energy management and asset health portfolio in a sort of real time as well. And that was the key success that that made this client to be able to choose this solution for their facility. So with that, I would like to thank the audience for your time today. It's been a privilege and a pleasure to be able to present on behalf of myself and the entire team. We will be running separate individual webinars within ABB itself as a product focus solution presentation. Please sign up for the invitation on those product and solution-based webinar. Scan the QR code on your screen, and you would be able to receive the invitation for the in-depth webinar that would be ran by ABB Australia. And you will be able to receive the invites as well, which is going to be held in September. Thank you.
Thank you, Milad. Well, now it's you, our audience's turn to get involved. So please ask our speakers your questions by the chat box. And don't forget to let me know who your question is directed to. Now, big thank you to everyone who submitted questions while registering for today's webinar. So we might actually kick off the Q&A with some of those questions. So what I might do is direct the first question to Adam, being that he's had a good break. And the questions come through from Sudhanshu from New South Wales, and it is, how sustainability can be incorporated in modern power supply system? Adam.
Thanks, Megan. From a power protections perspective, we're able to ensure that we've got the highest efficiency available from a UPS, both in low voltage and medium voltage situations, but also on the ABC side, so active voltage conditioner, with a very high efficiency of 99%. To correct any issues you might see on the grid there. Also, ABB has an Eco Solutions label, so that is KPI with 4 different points where we're looking at our design and sourcing, our efficiency operations, and optimize use phase, so the efficiency in the life cycle of the units, but also the responsible end of life, so our take back and our recycling habits on the products. So hopefully that's answered it from a power protection.
Awesome. Thanks, Adam. I've got a question that's come through, so I might direct it firstly at Sean, and it is, does ABB do enclosed ATS?
Thanks, Megan. Yes, true and ATS can be ordered with enclosed style, and ABB has enclosed true one with a delayed transition model with level 3 and 4 control unit, coming with the enclosure IP54. However, it's probably more convenient to order the ones locally assembled by IPD. IPD is our distributor for ATS and other products. These enclosures can come with mild metal, mild steel, or stainless steel with IP65. So that's for the true one. Milad, if you want to add your comments for the embedded ATS, yeah, please do.
Sure. Thanks a lot. Thanks a lot, Sean. Just follow on to add to that. So the embedded ATS circuit breaker based function is available to the market, to system integrators and panel builders who would like to essentially incorporate this into their own design or panel as well. Thanks.
Thanks, Milad. Soshin, I might direct a question to yourself, and it is, how would the condition monitoring system work with the control system? Would there be any control and tripping signals generated?
The control system, it's different. Yeah, normally in control system we do a lot of control. We turning on off the breakers and things like that, and it's really a lot of time more mission critical kind of things. Then you wanted to also pull in the protection functions and things like that. Yeah, but for condition monitoring system is really there for monitoring purposes only. Its intention is not to interfere with any of the plant operations. It's there to tell you the asset condition, how was it, and kind of thing. So it will not generate any tripping signal. Yeah, it will just generate alarm and telling you that there's something that you need to check in your next maintenance, or you need to plan a maintenance in between at your convenience, kind of things. Yeah, so it's not there it won't trip the system in short.
Thank you.
I hope I answered the question. Thank you.
Thank you. Now, I've got a question which came in live from Ramin. So thanks, Ramin, for watching. And this one, I think I should direct it to Sean. Is it possible to do boopless transfer using True One? I hope I've pronounced that correctly.
It could be bumpless transfer, and I probably need to have a separate discussion or a meeting with this whoever asked about this. But in this transfer time for the True One is less than 50 milliseconds, so load usually does not recognize the switching. And True One has unswitching neutral if that's the case and required for the specification. And True One comes with the open and delayed transition, but not with the closed transition. So if the customer is meant to say if the True One comes with a closed transition, no, it's not come with a closed transition. Also, True One can switch the operation from the automatic to manual operation even when power is on. So it also contribute about bumpless transfer. So we can discuss further what's the pain point, and if they need more information about that, I'm happy to discuss further. Thank you.
Thanks, Sean. Well, Adam, I've got a question which came through from David Carr, and his question is, with the introduction of renewables into the system, has this made maintaining uninterrupted power supply more difficult?
Thanks, Megan. Yes and no, but I'll answer it with the yes question to start off with. What we are seeing, especially on grids or remote type applications, when the sun is not shining or the wind is not blowing, you do tend to have a sag in that system. We are working with businesses in those situations and supporting them with our ABC 40 product, enable to make sure that there is clean, reliable voltage to their grid or to their application. These are only short duration sags, but they can be quite significant. So yes, it has presented some challenges. Obviously, we are looking to ensure that we are moving to as much renewable energy as possible. We just need to make sure that we're able to mitigate any of those challenges that the businesses may face in the transition or due to these green power supplies on the grid. Happy to take that offline and discuss with the person that asked that question any further, but hopefully that's answered it in some way.
Excellent, thank you. Malad, I'll bring you back into the conversation. So we had a question that came through. What are the protection functionalities that an embedded ATS is able to provide in a protection philosophy scheme?
Very good, great question. Obviously, a variety of protection functionalities are necessary for today's grid with the rise of solar and battery energy storage systems. When using the embedded ATS function via the circuit breakers, you would be able to incorporate functions such as overvoltage, undervoltage, reactive power protection related functions, all the overload, short circuit protection functions, over frequency, under frequency, or some of the main dominant item that we do see happening or being required more these days is the rate of change of frequency. So yeah, you would be able to incorporate quite a vast number of protection into your system.
Thanks, Malad. Soshin, I have a question which has come through for yourself, and it is the condition monitoring system only suitable for air insulated switchgear? How about for gas insulated switchgear?
Yeah, we have actually condition monitoring system which is suitable for air insulated switchgear as well as gas insulated switchgear. The one that we presented today here are mainly on the air insulated design kind of things. We'll cover the gas insulated switchgear condition monitoring in the detailed sessions that we're going to run in a couple of weeks' time. So do register if you're interested.
Thanks, Ocean. Shun, I have a question for yourself with regards to Insight, and it is: can a third-party meter be connected with Insight?
Yes, any of Modbus RTU or TCP/IP devices like energy meters can be connected to Insight. You need to configure the register map though, which should not take more than a few minutes. And also, we are working on pre-mapping the third-party Modbus devices such as most popular EV chargers or inverters or heat pumps of the other brands, so for easier integration to Insight. The list of this pre-mapped third-party device will be under the preparation and will be available once it's ready.
Thanks, Sean. Adam, I've got a question which has come through from Christopher, who's watching from Queensland. So hi, Christopher. And his question is: aside from battery backup, is there any other benefit to using an online double conversion UPS in place of an AVR for protecting sensitive loads? Adam.
Thanks, Megan, and thanks, Christopher. Yes, you can have additional benefits from using a double conversion online UPS, which is obviously you're using a rectifier and inverter to break the AC down to a DC bus, providing you separation from your grid, adding some additional layer of protection. You're also able to distribute the load on the input, so you can have a balanced supply from the input. What does need to be taken into consideration is what type of load you are supplying. If it's dynamic, that UPS would have to be sized appropriately. With our AVC product, for instance, you can have a 1-to-1 sizing profile with the load that you're looking to protect. So it really does need a little bit more thought sort of put behind it. But yes, there are some benefits, but there are also some considerations that you need to make. And that really depends on what type of load you're looking to protect, and also at what size you're looking to protect. If you're looking to protect a large load and you are looking to incorporate batteries, what does that battery look like? What does the space on site look like? Happy to sit down and have a discussion if you've got a particular application in mind. I really like getting my hands stuck into the solution side of the business. So if you want, reach out and we can have a chat.
Thanks, Adam. We've had a live question come through from Macross, and it is: what's the site? If I can get my words out, what cybersecurity measures have been included in Insight, and how is the cloud data managed? Is it by client specified or ABB managed? Now, I am thinking that a couple of you may want to answer this one. So did we want to kick off with
That should be
Sean?
me, Megan. Yes. So no worries. Insight 1.0 has SNMP protocols for the cybersecurity measures. It is basically more secure than the Modbus protocol, and yeah, that's basically it for the Insight. But for the cloud level, I think Milad maybe can add some more comments.
Sure. So thanks for the question. I would like to reemphasize with a fact that please remember, cybersecurity is really a risk management, and it will all depend on the way you would employ or you would be able to utilize a risk management technique. For that reason, here in ABB, we have ways of being able to assist both the client side and the system integrator partner. We do have both options available on the cloud version and on the local premise version as well. I hope that answers your question. Please feel free to make sure that you have your contact details there so that we can get in touch with you if you have an active project that we can assist. Thanks.
Thanks, Milad. The next question I'll direct to Adam, and it is, do you see that total cost of ownership is playing a big part in the market today? And if so, what is ABB doing to address this?
Thanks, Megan. Yes, quite simply, the businesses are looking at the full lifespan of their equipment, how much it's going to cost them day one with their capital expenditure, but also the operational expenditure of that product. So we are finding that the efficiency of these products is coming into play with regards to total cost of ownership. Also the maintenance. So are we looking at a predictive maintenance type approach? Are we looking at your standard sort of 2 visits to site type approach for a UPS application? But we're also here at ABB looking at or have provided longer lifespan products. So commercial UPSs with 15-year design lives, as far as the Megaflex is concerned. Also, industrial equipment has got long lifespans as well. Also, utilising our DPA architecture is a way that we're able to grow with you as the business grows. Or if you're looking to replace a product that maybe have been oversized in the past, you can use the right size frame to ensure that your cable reticulation does not need to be changed, and simply install the right amount of modules, DPA modules to support the load. But yes, we are definitely seeing a trend to ensuring that the whole life of the product is being taken into consideration right from the outset.
Thanks, Adam. Look, we've had a question a question come in live from Jackson, and his question is, what are the usual data capture metrics for PM works on ATS units? Milad, did you want to take that one?
Sure. I'm assuming PM means project manager. So with that assumption in mind, I would say the typical data point that you are able to receive or communicate from the ATS systems would be your typical electrical values, voltage, current, and then if you want to go a step further, you would be able to also get the power, reactive power, apparent power. And even if you want to go one step ahead, you are able to get the energy data related, which is quite a trend these days, because with that in mind, you would be able to technically provide the relevant energy consumption, and you are able to provide the benchmarking and therefore the optimization factor for your client. We will be running a separate sort of webinar around energy efficiency and ways that you are able to utilize this factor. I have to also emphasize that preventive maintenance items too is another key sort of data that is very useful that you are able to utilize from the ATS. So I hope that answers your question.
Thanks, Milad. I've got my next question will be to Adam, and is, how do we size a UPS for industrial loads, and is a UPS the only option?
Thanks, Megan. This is a common question that we get asked a lot, is how to size a UPS for an industrial load. It really does depend on what that load actually is. We need to understand the characteristics of that load. There is the potential that you need to size that to 4 times the size of the load, or even greater, depending on what that type of application is. There's also considerations around whether you need an isolation transformer, depending on what type of dynamic load that may well be. I think it's worth noting, I mentioned it a little bit earlier as well, it's worth noting that understanding what you're actually trying to protect that equipment with, as an ABC is able to be sized 1-to-1. So whatever the load you're trying to protect is the size of the capacity of the ABC that you would look after. The ABC does not have any energy storage. It is to support a clean voltage to that product, and that may well address all the requirements for that, depending on what type of equipment it is. But we also can have a look at using AVC and UPS in tandem. We've done that on many sites where the AVC is looking after a larger capacity, so looking at something like 1 or 2 MVA type AVC, with UPSs at the sort of IT side of things, or the control system side of this the facility or the operation, with a much smaller type UPS. So we can use a sort of a cooperative approach between an AVC and a UPS in the right place for the business or the operation, to ensure that they're getting the appropriate type of protection, depending on what their critical load requires. So hopefully that's answered.
Thanks, Adam. Malad, I've got a question for you. Please outline KA rating. My apologies, I'm not quite sure how to state KA, but in which embedded ATS can be used for.
Sure. So by KA rating, they would be referring to the braking capacity, current braking capacity in kiloamp. And we would be able to accommodate a number of KA rating with the ATS system, with the embedded ATS system, starting from 36 KA, 50 KA, 70 KA, 100 KA, and all up to 120 KA. Yeah, thanks.
Thank you. Look, I think we've actually come up to our final question for today. And this one is for Shun. And does Insight satisfy NCC J8 requirements?
Thank you, Megan. A good question. Happy to take the lucky last. NCC section J8, which requires the energy data to be centralized via a single user interface, where the information need to be stored and analyzed and reviewed. And Insight certainly can store the energy data locally, and the benchmarking function of the analytics will help to compare the two measurements of by device or the period. So short answer is yes. Insight most certainly can help to achieve NCC section J8.
Thank you, Shun. Well, look, that's all the time that we have for today. So please join me in once again thanking our speakers, Adam Cockshell, Shun Mizuta, Saw Shinto, and Malad Mustafa Bala, for their time and input. I would also like to thank Engineers Australia's industry partner, ABB, for their support today. Now, if I could ask for our audience, if you could please complete the short feedback form, which is linked in the description box below. Your feedback, it really does help us to improve and plan our future sessions. So finally, thank you for joining us, and we really hope to see you at our next Thought Leaders event. Good afternoon.